In some of the earlier videos, we looked at when given a function f of x equals sine of x here, the function looks like this. And when you apply this transformation, where you put 2x into this x here, then in effect you are squeezing everything inwards. You squeeze everything inwards here, so it in effect becomes a function. It becomes this function here. So when you start off with sine of x here, and then you apply this transformation here, you put this into here, so in effect it becomes this graph here. Okay, and when given this function here, and then you apply this transformation, it basically becomes this. Well, this is your f of x here, and because of this 2 times f of x here, your new graph basically becomes this whole thing here. Okay, so when given this function here, it looks something like this here, and when you apply this transformation here, everything gets stretched gets stretched in this direction here. Okay, well, with this function here, everything gets squeezed. Everything gets squeezed inwards in this direction. Okay, now we are going to there is a difference between this and this here. Okay, so anyway, now we are going to look at this transformation here. What happens when given a function, let's say sine of x here? What happens when we apply this transformation, where we put the x into when we have x plus 90, put it into here, then basically it becomes this. You can think of it as being y equals this thing here. So our new graph basically becomes this. Okay, now in this video we're going to see what this graph will look like. So here, when given a function, so when given a function, bear with me. So here, so we are going to investigate this function here. Well, we started off with sine of x. What happens when we have sine x plus 90? So let's have a look at this. Hang on. So this is our normal sine graph here. Now let's look at when x equals 0. When you put 0, well, don't forget we are trying to investigate this graph here. When you put 0 into the x here, 0 plus 90 will be, well, this whole thing here becomes 90. Okay, so it basically becomes sine of 90. Well, sine of 90 is this point here. So this point really gets dragged over here. Okay, so for our first point for x equals 0, it will be this point moving to over here. Okay, and so let's just put this here, and let's look at when x equals 90. Well, if you put 90 into this thing here, then it will be 90 plus 90. So really it boils down to you doing sine of 180. Okay, well, sine of 180 means this point moving over here. So earlier we had this point moving to here. Now we've got this point here moving to here. So it basically becomes this. Okay, now let's look at this. When it's at 180, put 180 into here. So 180 plus 90. That really boils down to 270. So it boils down to you doing sine 270. Well, sine 270 is down here. So that then gets moved over to here. Okay, so and then this point gets moved over to here. So basically it becomes this. And then well, if you continue, it will look like this. So basically this graph here is sine of x, but everything gets shifted over to the left by 90. Well, remember from our section on transformation, no matter what graph you have, well, no matter what function you're given, let's say this function here, Yeah, if at the moment this is a function of f equals x here, whenever you have f equals x plus 90, then everything gets will get shifted across by 90. So this point here will move to here. Let's say this point here, it will get shifted over to over here. If this point here, it will get shifted. Well, if you don't understand this bit, watch the earlier section on transformation. If you have plus 90, then everything gets shifted across by 90. So here, well, basically, if you have a function f of x equals sine of x here, and you want to know what happens when you have sine x plus 90, then it basically everything gets shifted across by 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 90. Okay.